Hello. In this video, we will be going over static pressure and dynamic pressure. Before we get into that, let's go over absolute pressure. So pressure is just a force over the area in which that force acts. As we can see here, the equation is going to be pressure equals force over area. The imperial units are going to be pounds per square inch or pounds per square foot. And metric units are going to be, this is going to be a Pascal, and that will be equal to a Newton over meter squared. So absolute pressure is the pressure of a system relative to ideal vacuum. So absolute pressure will be 0 for an ideal vacuum, and absolute pressure must always be a positive value. You can't have a negative absolute pressure. Now, as opposed to absolute pressure, we have relative pressure. Before we go over relative pressure, we have atmospheric pressure, which is the pressure exerted by the atmosphere. And this will also be known as barometric pressure. And STP pressure at sea level is going to be around 101,325 pascals, or 14.7 pounds per square inch. We have gauge pressure, which is going to be the difference between the absolute and atmospheric pressures. And when absolute pressure is less than atmospheric pressure, the gauge pressure is referred to as vacuum pressure, and that's just simply a nomenclature thing. And an example of this is right here. We have something called a manometer. So we'll go over this later when we go over Bernoulli's equation. But right here, where at the neck where the area gets smaller, the fluid will speed up, which will cause the pressure to go down. So the pressure here will be higher than the pressure here. And this relative pressure difference is shown by the manometer, where this side of the fluid is pushed down further than this side, which causes this height difference. Now we have static pressure versus dynamic pressure. So static pressure is going to be the pressure exerted when a fluid is at rest. This is as opposed to dynamic pressure, which is the pressure exerted by a fluid due to its motion. So the best way to illustrate this is going to be Bernoulli's equation, which is pressure plus 1/2 times the density times the velocity of the fluid squared plus the density times the gravitational constant times the height. And this will be constant. You can set this equal to a different area of whatever system, such as a pipe you're looking at. Static pressure is going to be these two components of the equation, the pressure plus density times gravitational constant times height. And the dynamic pressure is going to be the component that includes velocity. And as we can see by this, an increase in fluid velocity will lead to a decrease in pressure, as we said earlier with the manometer. Total pressure is just simply going to be the sum of static and dynamic pressures. If we go back to the manometer back here, the way we would calculate, for instance, the pressure at this point right here, is we would know the incoming pressure, most likely atmospheric pressure or whatever pressure you have in the pipe system, and you would do pressure plus rho GH equals the pressure at point 2. And we have the height difference can just simply be measured by a ruler. So that's kind of how you would use a manometer. And these are used in plenty of applications, such as older pipe systems or older wind tunnels will use these. So I just wanted to end off by giving an example of an application for these concepts, the pitot-static tube. If you've ever looked at the front of an airliner, you've likely seen a tube sticking out from the side of it. This is a pitot-static tube, and it's used to measure an aircraft's airspeed. Right here, these side ports are only going to measure the static pressure because their normal direction, which is the direction extending perpendicular to the opening, is perpendicular to the airflow. The front port will measure the total pressure because its normal direction is parallel to the airflow. I'm not going to get too far into this, but the pressure at the front is going to be caused by the stagnation point that will form there. So then you can calculate the dynamic pressure by taking the difference between the static and total pressure measurements. And if we go back here, as we can see, we can use the dynamic pressure we get from taking the difference between the static and total pressure, multiply it by 2, divide it by the density, and then take the square root to get our velocity. Thank you for watching this video. Here are my image sources, and here are my text sources. I will have them linked in the description below. If you have any questions, please feel free to leave a comment. And thank you for watching, and have a great rest of your day.